Okay, finally we consider the third term. So here I will consider the third term. So consider the third term, which is sum over ij integral from 1 to 2 if ij internal dot dri. Now this sum over ij, and we have this fij. If we have two particles, if the system consists of two particles, then this summation can be written like this: f12 and sum with this dri. Okay, this can be written as f12 and we have dr1 plus f21 dr2. f12 means particle 2 exert a force on 1 and f21 means particle 1 exert a force on 2. Now these two forces f12, they are equal in magnitude. f12 is equal to f21, but they are in opposite direction. For example, we have two particles. This is particle 1, this is particle 2. So this particle 2 exert a force on particle 1, which is f12, and similarly this particle 1 exert a force on this particle 2, which is f2. So the two forces are equal in magnitude, but their direction is opposite. One direction is this one direction is this one. So similarly, we can also write this term like this. This whole term is a sum of two terms. Sum over ij, and we have this integral from 1 to 2. Now this fij dot dri, I can write it like this: fij dri plus fji drj. But we know that fij is equal to minus fji, or fji is equal to minus fij. So I can write this here like this: sum over ij integral from 1 to 2. We have this fij dri. Now we have this fji. I replace it by minus fij, and we have drj. Now this can be written like this: sum over ij integral from 1 to 2. We have fij is common here, so I take it common. Okay, and then we have, there is a dot product also, yes. Then we have, here we left with dri minus, here we left with drj. Now dri minus drj, if we have two particles with respect to some origin, one's distance is dri and the other one is rj, then this will be drij. So this dri minus drj can be replaced by integral from 1 to 2 fij drij. Now this is the internal forces, so I put internal here because we have this internal force. This is the internal force, so we have internal force here. So here we have also the internal forces, here we have also the internal force. Now we finally got this expression from which one? This one: sum over ij integral from 1 to 2 if ij internal dot dri. Now this is the internal force. Now if ij internal is conservative. It's a conservative force. Then this implies that this Fij internal can be written like this, minus negative gradient of the potential. But the gradient is Ij and the potential is Ij. So here I replace this by this term, which is sum over Ij, and we have this integral from 1 to 2. Now Fij internal is replaced by this one, so we have negative sign here, and we have this delta Ij Vj, and then we have drij. Here we have also Ij. Now this term, which is basically like this, del V into dr, and this can be written as dV. So here we can write it as like this with a negative sign Ij, some integral from 1 to 2 v dv Ij. Now this can be written like this, which is equal to minus with sum over Ij, and we have this integral with dv Vij. So if I integrate it, we get Vij, but this is internal, okay. So we have this limit of the integral is from 1 to 2. Now this can be written like this. This is equal to sum over Ij with a negative sign here. We have Vij internal with configuration with upper limit minus sum over Ij Vij internal with lower limit, which is 1. Or we can write it like this. If I apply the minus sign here, then this term comes first, which is sum over Ij Vij internal at configuration 1, and then we have this term minus sum over Ij Vij internal at configuration 2. So this term represents the potential energy of the system at configuration 1 and this represents the potential energy of the system at configuration 2. So overall I can write like this. On this side we have this, on the left hand side we have this term, which is sum over Ij integral from 1 to 2 if Ij internal dot dri, which is equal to, now this is the potential energy V at configuration 1 minus V at configuration 2, but these potential energies are due to internal forces, so I put internal in the superscript. So this is equation number D. Now we have four equations. We have 4 equations. Equation A. Okay. Now this part of the equation is this one B. So here on the right hand side of this equation I will put this term, which is T2 minus T1. So using equation B, C and D and equation A. Now equation A is this one. So this part is equal to this one, which is T2 minus T1. Okay, which is equal to, now this term is represented by this one. We have this Fi external dri with integral 1 to 2 with summation, which is this term, which is equal to V1 external minus V2 external. So we have V1 external minus V2 external. Then we have plus this term, and this term we already calculated here, which is this one. So this term we already calculated here, its value is this one, which is V1 internal minus V2 internal. So it means I will rearrange the term now. We have T2 minus T1, which is equal to, I have V1 external, here I have V1 internal plus V1 internal, and then we have minus sign, we have V2 external minus we have V2 internal. So if I keep minus sign common, then we have this will become positive. Now this is the potential energy at configuration 1 due to external force as well as internal force. So this is the total potential energy at configuration 1. So we have this T2 minus T1 is equal to, this is the total potential energy at configuration 1 minus, and this is the total potential energy at configuration 2. So potential energy at configuration 1 is basically equal to potential energy at configuration 1 due to external forces plus potential energy at configuration 1 due to internal forces. Similarly, total potential energy at configuration of position 2 is equal to potential energy at position 2 due to external forces plus potential energy at position 2 configuration 2 due to internal forces. So I replace these two terms, V1 external plus V1 internal, by this V1, which is the total potential energy at configuration 1. Similarly, I replace these total two terms, which is V2 external plus V2 internal, by V2. So we have this. Now this can be further simplified like this. So we have this T2. I bring V2 to this side, so this will be V2. Now if here we have V1, I'll bring this T1 to this side, so we have plus T1. This can be written like this. I write this term first, which is T1 plus V1, which is equal to T2 plus V2. What it means? It means that the total energy, now this is the total energy, because kinetic energy plus potential energy is equal to total energy. Total energy is always represented by this E, which is equal to kinetic energy plus potential energy. So this is the total energy at configuration 1, which is equal to total energy at configuration 2. Now what it means? It means that this equation shows that, I will write the extra statement here. So we have this T1 plus V1 is equal to T2 plus V2. Now this is E1, this is E2. This is the total energy at position 1, and this is the total energy at position 2. So I can write this statement here that this equation or this equation, both are the same. This equation shows that the total energy of the system of particles is conserved, because the energy of the particle at position 1 is equal to the energy of the particle at position 2. So energy can neither be destroyed nor be created nor destroyed. So what it means? It means that the energy is conserved. The energy remains constant, and this is called the law of conservation of energy. This is called the law of conservation of energy of the system of particles. So I'll stop my video here. Thank you.